Hello good day viewers. In this tutorial I would like to show you how to find the square root of a radical expression. And this is the radical expression we have 3 minus 2 root 2. We want to evaluate the square root of this radicand 3 minus 2 root 2. I'm going to show you two different ways to do that, the shortcut way and the traditional way. Let's start with the traditional way. Let's start with the shortcut. To do that, you have to ensure that the radical expression is written in terms of a plus 2 root b. If you have something like this, you have to ensure that you have 2 right here before the radical expression. If you have something like this, all you have to think of is 2 numbers that you can multiply to get this b. But when you add them together, you get a. And you should know that this can be plus or minus, it doesn't matter. So that number, let's assume if we take c and multiply by d, that will give us b. And if we add c to d, that will give us a. Once you can find these numbers c and d, then you're good to go. Then you can take c under root plus or minus, then d also under root. But you should make sure that if you evaluate this, it has to be positive. So we can come back here, since we have a and b here. This is our a, this is our b. All we have to find are c and d, 2 numbers we can multiply to get 2. But when we add them together, we have to get 3. The numbers are 2 and 1. It could be 1 and 2. It doesn't matter, right? Then you take their roots. Then attach that sign, minus. But you know that this is what? 1 minus root 2, which is negative. We don't want it to be negative. But this will be root 2 minus 1, which is positive, right? So therefore, this is the solution to this problem. This is equal to root 2 minus 1. That is just the answer. But let me show you the traditional way to do that, the standard way. You have to take the whole of this, which is 3 minus 2 root 2 under root, and you equate it to be equal to a plus b root 2. If it is root 3, it should be root 3, root 4, root 4, root 5, root 5. You understand? Then take square of both sides. If you square the left hand side, it will eliminate the square root, leaving the radicand 3 minus 2 root 2. And you have to square the right hand side, a plus b root 2 whole squared. This is 3 minus 2 root 2 equal to first term squared, that is a squared. Second term squared, this is b squared. This is 2, that is 2b squared. 2b squared. Then plus 2 times this, 2ab root 2. This is the expansion. Then if you observe, we can relate this with this, right? And this with that. We're going to equate them, which implies that the whole of this a squared plus 2b squared, this must be equal to 3. And the whole of 2ab root 2 must be equal to negative 2 root 2. So we have just equated the rational and the irrational parts. These are the rational parts. 3 is the rational number here. 2 root 2 is said to be the irrational side. Let's simplify this. You can see that 2 will cancel 2. Root 2 will cancel root 2. So we have ab to be equal to just negative 1. And what can we can make b the subject or a, it doesn't matter. I can say that this implies that b is equal to negative 1 over a, which we can now plug into this equation. If you plug it back here, you have a squared plus 2 times b, but b is now negative 1 divided by a. Negative 1 divided by a whole squared. Remember, the whole of this equal to 3. We are moving. If you expand this, it will be 1 divided by a squared. This is a squared plus 2 times 1 divided by a squared is 2 divided by a squared. I can subtract 3 from both sides, and this is equal to 0. Let's multiply every single term by a squared. A squared times a squared will give us a to the power of 4. Then I can decide to start with this one before this. If I should multiply this by a squared, that will give us negative 3a squared. Then if I should multiply this by a squared, it becomes 2. And this is equal to 0. All right. We can factorize this. All we have to do is to think of two numbers we can multiply to get 2. But when we add them together, we get negative 3. The numbers must be negative 1, negative 2. All right? So this becomes a to the power of 4 minus a squared minus 2a squared. That will give us negative 3a squared, then plus 2. This is equal to 0. We can now simply factorize the batches. A squared and a to the power of 4 and a squared has a squared in common. So we have a squared outside. Inside, from the first term, we only have a squared. From the second term, we have minus 1. Then from these 2 times, I think they have minus 2 in common. Minus 2. From the first term, we have a squared. From the second term, we have minus 1. If you expand this, you shall obtain this 2 times back. This is equal to 0. A squared minus 2 multiplied by a squared minus 1, right? This is equal to 0. So it implies either this or this must be equal to 0. So if a squared minus 2 is equal to 0, it implies that a squared must be equal to 2, right? A squared minus 1 equal to 0, it implies that a squared must be equal to 1. So you can see that we're going to have how many values of a? 4. From here, a can be equal to square root of 2. A can be negative square root of 2. From this one alone, if you take square root of both sides. And this one, a can be positive 1 by taking square root of both sides, or a equal to negative 1. Just observe, we have 4 values of a. But what is going to be the value of b? We're going to take it from here. Remember, b is equal to negative 1 over a. So if I should plug this one, let me start with this one. If I should plug it here, it is going to be negative 1 divided by root 2. So b here will be negative 1 divided by root 2. What about if I should take this one? Because of the negative, it will be positive. So b will be 1 divided by root 2. Then if I should plug 1, we have negative 1 divided by 1 is negative 1. So b here will be negative 1. If I should plug negative 1 here, it will be negative 1 divided by negative 1, which is positive 1. So these are the values of a and b. Where should we plug them? We have to plug them right here to find our final answer. So let me take down all of this. So our combination, a plus b root 2. So let's take the first combination. We have a to be root 2. B is negative 1 over 2. Negative 1 over root 2, sorry. Times another root 2, which is right here. You see that this will cancel this, leaving only root 2 minus 1. So let me write it directly here. I don't have much space. This is our first solution. Then the second solution, we are going to take this combination. Negative root 2. B is what? 1 over 2. So plus, because of this plus. 1 over root 2 times root 2 will give us 1. So let me just write 1 here. Then the third combination, when a is 1, b is negative 1. If you plug in negative 1 here, it becomes negative 1 root 2. That is negative root 2. Can you see that? Then the third combination, when a is negative 1, this is negative 1. B is positive 1. So we have 1 root 2. That is just root 2. Remember, I told you the output must not be negative. It must be positive. So you know that this and this will give us what? Negative result. They are all exactly the same. Just look at it. You know, it is commutative. Negative root 2 plus 1 is the same thing as 1 minus root 2. So we don't want this solution. And if you observe, this and this are the same because it is commutative. Root 2 minus 1 is the same thing as minus 1 root 2. Right? So if you like, you can take this one or this one. If you want to write the rational part before the irrational part, you consider it as this or this one. It doesn't matter. So these two are exactly the same, and you can see what we have previously. So the final answer is root 2 minus 1. As simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.